Assalamualaikum and a very good morning, ABDUL. My name is AMIERA SOFEA binti Abdul Wahab with matrix number 01DKA21F1130. Today, my team and I would like to present about the integration for our course DBM 20023 and introduce our lecturer, Miss Liana binti Rosli. First of all, allow me to introduce my team members, which is NADIAH HUSNA binti MOHAMAD ZAINURAIN 01DKA21F1135. Next is Muhammad HAZIM bin Abdul MUTALIB 01DKA21F1115. And the last one is Muhammad NASRULHAQ bin Muhammad NAJIB 01DKA21F1157. So, this is our team role and responsibilities for this assessment. Introduction of integration. Integration is an action of making something whole by combining the things together. Generally, integration means a thing or people that are integrated and have been brought together, where they all live and work together, which mean united. In mathematics, an integral is a function of which a given function is derivative. Integration is a simple way to find out the area under a non-linear function. Integration also a method of adding values on a large scale where we cannot perform in general addition operation. Basically, integration was used to find the areas of the two-dimensional region and for computing volumes of three-dimensional objects. For your information, integration is the reverse of differentiation. If the integral of 3, it can be 3x plus 4, 3x plus 6, 3x, and so on. For this reason, when we integrate, we have to add a constant. The constant of integral is c. For example, the integral of 3 is 3x plus c. Did you know why integration was used in maths? The answer is integral was used to find many useful quantities such as areas, volumes, displacement, and more. Then there are two types of integrals. Definite integrals are defined for integrals with limits, and indefinite integrals do not include any limits. Here, let us explore more about definite and indefinite integrals. Application of integrals in real life. Application of integrals also includes finding the area enclosed in the ellipse, the area of the region bounded by the curve, or any enclosed area bounded in the x-axis and y-axis. The application of integrations varies depending upon the fields. In mathematics, integrals are used to find the area between two curves, the area under a curve, the center of mass, which is the centroid of an area having curved sides, and the average value of a curve. In engineering, integrals are used to find the shape of a building. Besides, in physics, integrals are used to find the center of gravity, the distance, velocity, and the acceleration, the center of mass and moment of inertia of vehicles, mass and momentum of satellites, and the velocity, also the trajectory of a satellite. Last but not least is graphic designers use the integrals for the creation of three-dimensional models.
Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Muhammad NASRULHAQ bin Muhammad NAJIB and my registration number is 01DKA21F1157, and today I'm going to take part on how to calculate the area of the region. Okay, now we're going to the first point, and it is to determine the point of intersection A and B between the two lines. And as you can see, there's two lines that have been given, and it is y is equals to 1 over 3x to the power of 2 and y equals to x plus x. And the first things that we need to do is we need to use the simultaneous equation. So as you can see here, there's two equations that have been given, and it is y equals to 1 over 3x to the power of 2 and y equals to x plus x. And the reasons why is equation 1 is equals to equation 2 is because all of it is y. So y is equal to y. And as you can see, after we put it the first equation and second equation in the equation, it's going to be 1 over 3 x to the power of 2 is equals to x plus 6. And then we're going to arrange it into the quadratic equations. So the quadratic equation is going to be x to the power of 2 minus 3x minus 18 equals to 0. And after that, after we factorize it, we're going to find x minus 6 and x plus 3 equals to 0. So the answer is going to be x equals to 6 and x equals to negative 3. Okay, now after we've found our x, so now we're going to find a y. So when x is equals to 6, so y is going to be 6 plus 6. And the final answer is going to be 12. And then when x is equals to negative 3, so y is going to be negative 3 plus 6. And the final answer will be 3. So after we've found all of it, we have already found our intersection point. So the intersection point is 6, 12, and negative 3, 3. Okay, now to the next question, and it's going to be point B. So point B is need to determine the y-intercept point. So first, we need to find the gradient, and the formula for gradient is y2 minus y1 over x2 minus x1. So m is gradient, and then we're going to be minus all of it. So 12 minus 3 over 6 minus bracket minus 3. So the final answer is going to be 9 over 9. So the gradient is 1. And then to the next step, we're going to find the intercept point. This is the point that we need to find. So we're going to use the formula of y is equals to mx plus c. So as you can see, we've put all of it in the equation. So y is going to be 3 and m is 1. X, we're going to take the negative 3 plus c. So the final answer, the c is going to be 6. So the equation is going to be y is equals to x plus 6. Okay, now we're going to the last point, and it is to determine the area under the curve for the region bounded by the curve at the axis. So now we're going to the solution of the area. So we need to use the formula of integration. So now as you can see, the integral x plus 6 from negative 3 to 6 minus 1 over 3 x to the power of 2 dx. So then we're going to separate both of that, and it's going to be the integral of x plus 6 from negative 3 to 6 dx minus the integral of 1 over 3 x to the power of 2 from negative 3 to 6 dx. And then to the next step, we're going to use the formula of integration. So it is going to be x plus 6 to the power of 2 over 2 from negative 3 to 6 minus by 1 over 3 and then x to the power of 3 over 3 from negative 3 to 6. And negative 1 over 3 we're going to multiply by x to the power of 3 over 3. So, and then to the next step, we're going to put the number that has been given into the x. So it is going to be 6 plus 6 to the power of 2 over 2 minus negative 3 plus 6 to the power of 2 over 2, close the bracket, minus by 1 over 3 multiplied by 6 to the power of 3 over 3 minus negative 3 to the power of 3 over 3. So the answer is going to be 72 minus 9 over 2, close the bracket, and minus 1 over 3 multiplied by 72 minus negative 9. So it is going to be 135 over 2 minus 1 over 3 multiplied by 81. So negative 1 over 3 multiplied by 81 is going to be 27. And the final answer after we've done minus it is going to be 81 over 2 units square.
In conclusion, integration is the calculation of an integral. The indefinite integrals are used for antiderivative. Integration is one of the two major calculus topics in mathematics, apart from differentiation, which measures the rate of change of any function with respect to its variables. The integration denotes the summation of discrete data. The integral is calculated to find the functions which will describe the area, displacement, volume that occurs due to a collection of small data which cannot be measured singularly. In a broad sense, in calculus, the idea of limit is used where algebra and geometry are implemented. Limits help us in the study of the result of points on a graph, such as how they get closer to each other until their distance is almost zero. That's all from us. Thanks for watching.